Thank you guys, everyone, for your patience, and I guess we'll go ahead and get started here. First of all, I'd like to thank WEI for the opportunity to host this webinar, and please go ahead and feel free to put in any questions you might have into the chat feature. There's a button on your control panel there that should allow you to type those in. We'll address questions here at the end of the presentation. So welcome to our webinar about PG&E's efforts in finding and fixing super emitting leaks. Go ahead and see if my slides work here. There we go. I'm Aaron Van Pelt from Picarro. I'm responsible for product strategy here at Picarro, and I'm joined by my co-host, Jessica Kamal, who's the leak survey process manager at PG&E, and so she's been very much involved in their efforts on running their super emitter survey program. I'll go ahead and give a brief introduction to advanced leak detection technology, which Picarro has been involved with and pioneered along with PG&E back in the 2011 timeframe. They're our local utility, and they were an obvious partner for us and have been incredibly supportive of us as a company in terms of really learning how to make products for the gas industry and best practices and understanding the challenges the industry has and how we as an equipment and software analytics provider can address those challenges. In great measure, PG&E's been pivotal in the development of the emissions quantification aspect of our technology, which has become a really important topic of conversation in the gas industry as a whole, as utilities and gas operators are being challenged to really accelerate their ESG measures with respect to emissions reduction. And so the super emitter process is a really novel way to get ahead of those emissions, and it's been really a pleasure for us to work with PG&E to develop that. So let me talk a little bit about advanced leak detection. And you may be familiar with Picarro as a very sensitive leak detection device in a car, but that's almost the least important part. Most of the power that we're able to bring to bear on, in this case, identifying super emitters, comes from the ability for us to take that data that's been measured by the car and analyze it in kind of a big data analytics fashion that's become available to us in the last couple of years, to tease out information from these plumes that tell us things about the leaks from which they're coming and allow us to make more intelligent, better decisions about asset management overall, leak survey, and in this case, identification of super emitters. So these cars drive through a network. PG&E has 10 of them, and they collect methane and GPS data in the infrastructure. And that data is brought into our data lake, where we combine it with, importantly, the GIS information about where the gas assets are. We have other pieces of information we can bring in for other purposes. And depending on the application that we're looking at, whether it's leak survey, whether we're looking for super emitters, whether we're trying to bring data in to improve our type replacement and DIMP models, we have different algorithms that allow us to ingest that data and put it out in a format that is fit for purpose in terms of the application we're trying to address. And so, as I said, the vehicle aspect of it allows us to go into an infrastructure and take data at the speed of traffic. So that allows the collection of this methane data in a gas distribution network at a speed and scale that hasn't been possible before. And because we're taking data 4 times a second as we drive through a network, we're able to amass an incredible amount of data from which we can tease out things like emission rate. And here you see the little map is actually a map of super emitters, and the size of the circles indicate the different flow rates. And so the vehicle, just briefly, we have an inlet. We're bringing air into the instrument in the back, which is a very sensitive parts per billion level methane and ethane cavity ring down spectrometer. We are combining that with the GIS information and the GPS position information as we drive through the network. And on top of the car, we've got an anemometer, and that allows us to understand the wind direction, the wind speed, and the wind variability. So all these atmospheric pieces of information are really important to us in assembling information about what these plumes look like and the things the plumes are trying to tell us about where they're originating. So that's best illustrated in this little picture. So we drive through the network and we say the wind is our friend. We use the wind to bring the methane plume to the vehicle. And this is really the hallmark of what advanced leak detection, ALD is the term that's being used in the industry, or advanced emissions measurement technology is all about. There's really two things. One is we're using the wind to bring the data from the plume to us, or bring the plume to us, and we intersect it as we drive through. We're also using a very, very sensitive device. And so the advanced piece of it is the fact that this is 1,000 times more sensitive than anything that's been used in prior decades for methane detection. We're also detecting ethane to tell the difference between natural gas and not natural gas. We also have the ability to screen out vehicle exhaust by measuring some other species, since cars with without catalytic devices and motorcycles and things like this also emit methane. So we want to eliminate those sources of methane from our consideration of whether or not it's a leak. So what we do, we drive through this area in purple is called the field of view, and that basically is where we have effectively seen or surveyed. It is a measure that we calculate 4 times a second, and it varies depending on the wind variability and the time of day and so on. And it tells us effectively how far away can we say that we've cleared an area. So the areas that are covered with field of view that don't have a leak indication on them are areas that we're saying, look, there's nothing there. And there would be, it's effectively covered from a compliance leak survey perspective, or, it's been measured from a super emitter scan kind of perspective. Areas where there is a leak, so if we drive through this plume, I know the wind's coming from the left-hand side of the vehicle, so I say, okay, I know that there's a potential leak on this side of the vehicle. The size of the plume tells us something about how far away we are. You can remember back to sitting at a campfire, and the plumes from the smoke plumes get bigger and bigger as they propagate. We also can understand things like flow rate, because we can essentially count the number of molecules going through our path, because we're measuring the wind velocity. So those things, as well as, is it an above ground leak? Is it a below ground leak? We have the ability to tell based on things in the plume that we can measure about that aspect of the potential leak, and also about aspects about whether there's a potential that this might be a hazardous leak. So kind of a risk level is another thing that we can measure. So that all is a concept that we developed and pioneered a methodology around, partnering with PG&E in the earliest days of developing this technology. Now you might say, what about the other side of the street? Well, that's the important part about this, is that, yeah, you can have a wind measuring sensitive device, but if you don't follow a very prescriptive protocol, you don't get good coverage across the network. And so we've developed through a lot of work with our utility partners, a very specific protocol that guarantees practically 100% coverage in a network like this. And so the little pictures here show you the purple assets, mains, and services, and 3 drives. So we do 3 drives across 2 different nights, or at least 2 different nights, with 2 passes on every street or area where there's gas assets. And you can see that the wind on the first drive is more or less from the northwest. I wait a couple hours later, and believe me, it's surprising how much the wind direction changes in just a short amount of time. But I get very different looking winds at different points in time. Some nights you've got more prevailing winds, so if you spread that over 2 nights, you end up getting great variability in direction, so that when you combine all this stuff with a report, with analytics, so the data is taken, indications are not provided in the car, especially not for super emitter driving. That all happens after the analytics combine everything in a report and produce actionable search areas for looking at, in this case, the super emitter. You know, it's an area where you've got to go and have someone with a ppm level handheld device to diligence those assets highlighted in yellow to find the leak or leaks. Statistically, there's sometimes more than one leak there, to find and grade and assess the leak, you know, in a traditional by traditional means. So the point here is that we're taking this data at nighttime when the atmosphere is well behaved, the plumes are not disturbed by atmospheric turbulence, we're not having cars do the same thing, disturbing the plumes, and we're also not having to deal with traffic. So the 6-drive protocol over 2 nights is really critical in getting really good data, really good plume measurements, and effectively getting a very high probability of seeing all the leaks in that infrastructure, or nearly all the leaks. So why do we need such a sensitive detector? Well, leaks come out of the pipeline at 95% methane or so, and by the time they've traveled the 500 feet that we max out our field of view with, they're down in the ppm level. So we can effectively see a half a cubic foot per hour leak at about 500 feet away under ideal conditions. And we're always calculating how far that field of view reaches based on the wind conditions. So in the daytime, it's much shorter because the day winds, the daily turbulence of the atmosphere is mixing up this plume, and it makes it much harder to assess it, and it makes it much harder to see plumes from further away. So that's the advantage of having that ppb level methane and ethane detection. And again, we're using the ethane to distinguish between natural gas and not natural gas, and taking out things that we're, after seeing them 6 times, remember we're driving 6 passes, after you develop that statistical evidence from that particular plume, you're better and better and better able to tell whether or not it's actually a leak, and you're better able to tell exactly what its flow rate is and so on, the more times you see it. So that's why the protocol is really important, so that you detect the plume many times and you build up that statistic. And this is another reason why, you know, if you can put the car in an emergency survey mode, where if you drive through a plume, you immediately get an indication, but you're not sure necessarily that that's going to be a gas leak. And so for a compliance leak survey application and the super emitter survey application, you want to collect all the data first and then run a report, and then find out what actually is actionable at that point. So just another note about the difference between advanced leak detection and traditional detection. The main thing is we're using the wind. The secondary thing is it's very sensitive. And because we're using the wind, it doesn't matter where the leak is. If it's within the field of view, that plume is going to arrive at the vehicle. It goes over and around houses. It always eventually gets there, pretty much. And because we don't need to worry about GIS conflation errors, we, did the person in the field walk directly over the line or not? Are the markers correct? Is the service line perpendicular to the house or not? Is the GIS accurate if service lines are even mapped? All of these things, including, was it windy the day the person was out there and the wand was in the wrong place and so on. This is why, and it's not that traditional survey personnel are not doing a great job. It's just that we've got a better mousetrap these days. It's more sensitive. We're using the unfair advantage of the wind to bring the methane plumes to us, and we therefore can do a much better job at detecting leaks. It's typically 90% efficient at detecting all the leaks in an infrastructure, whereas traditional surveys in the 30 to 40% level. And that's really just because it's removing that human error, and we're less sensitive to weather and things like that. And so the advantage here too is a lot of the super emitters, the reasons that they're there, the reasons that they haven't been smelled by the public and brought in as an odor call, is they might be in remote areas, or they might be migrating so far away that they're not detected by leak survey. So it's been surprising to us in some cases. PG&E is like, why? How has this not been found before, and it becomes a super emitter. So that's what's really has been interesting in working with PG&E on in this program. So I talked about compliance leak survey. There are applications for which finding leaks is not really the ultimate point. Certainly super emitters is, but we're only looking at leaks that are defined above the, in this case, 10 cubic foot per hour super emitter threshold. And that's a kind of an arbitrary number, but if you look across the distribution landscape, that's a pretty big leak for a distribution system, and that's about right. I mean, you could go down to 8 or whatever, but more or less 10 is what people are saying is a super emitter. So depending on what we're trying to do, we've got different fit for purpose algorithms and outputs. On the left, we've got the super emitter output, which the sizes of the circles tell us the relative flow rates. For adding this data into a pipe replacement program, we can aggregate methane data along GIS pipe sections and say, how many leaks do we predict are along that pipe section? Because we can, remember, we can distinguish in some way above ground versus below ground. We might use that data to better inform DIMP programs, to better take leaks out of the infrastructure with capital replacement money rather than finding these leaks in compliance survey. That's a different application that's kind of beyond what we're talking about today. The other one is looking at emissions heat maps, trying to understand if we go into this area for compliance leak survey, what's the labor aspects of, what are the labor aspects of leak survey and repair that we're going to have when we go there in terms of how impacted that area is, just from a very regional methane mapping perspective. And so there's a number of ways you can use this data that we're seeing the industry take advantage of to make better decisions about holistically managing assets. So let's refocus our discussion here about specifically PG&E's super emitter program. So this is what 2018 looked like. So in 2018 they began the super emitter program. PG&E surveys a third of their network annually for compliance leak survey with Picarro. The other 2/3, starting in 2018 and going forward, is driven for the purposes only of measuring and finding and fixing super emitters. And so that 2/3 plus the 1/3 in 2018 resulted in 210 super emitters. And Jessica will talk more about the statistics there, but that's a small fraction of the number of leaks that are in the infrastructure. That represented around 30% of the emissions. So these 210 leaks accounted for 30-ish% of the emissions as measured by Picarro within the network. So that means, back to the meeting the ESG goals, you can make a huge dent by fixing 210 leaks in a year. And that was really remarkable for us to see in these first surveys that were done for super emitters. The other really awesome thing that we saw was that on the 2/3 of the network that wasn't being surveyed for compliance, there were quite a few grade 1 and 2 leaks. And so not only are you getting, by fixing these 210 leaks, you're getting a great benefit on the emission side, you're getting a really unexpected benefit on the safety side. And here's what the breakdown of these leaks looks like. So nobody's surprised that most of the leaks in a compliance survey are turning out to be grade 3s. They're just more numerous than the others. But the thing that was surprising is that most of the super emitters are grade 1 and 2 leaks. They're the important ones. So it's this great safety benefit that everybody was really excited about. And it goes to, it stands to reason. These are big vent rate leaks, and so they're likely to be more towards the important grade leaks. So this is what the networks across the US and Europe look like. So we've got a number of customers that where we've been able to aggregate the emissions data of these several 100,000 leaks. And it's the fat tail everyone is very familiar with. Most of the emissions come from a very small number of leaks. And so if you want to do a great job of emissions reduction, focus on the fat tail, focus on the biggest, highest emission leaks that are very, very, very much lower in prevalence in the infrastructure. And the Super Emitter program that Jessica will talk about is exactly how to approach that. So with that, Jessica.
Awesome. Thanks, Aaron. Hello, everyone. Just a quick introduction. As Aaron mentioned earlier, my name is Jessica Camel. I am the leak survey process manager at PG&E. I've been with the company since 2014, and I've been part of the leak survey program since 2017. And since then, our program has gone through many changes, one of them being the implementation of the Super Emitter program. So to start, I'll be going through an overview of the timeline, some background on how this program came to be, the regulations that were passed, and then how we kicked off the program within the organization here at GAS at PG&E. So that first slide here, so we'll start with the leak abatement OIR, which is the order instituting rulemaking decision. This was initiated as a result of the Senate Bill 1371 that was passed back in September of 2014. And really the whole purpose of this rule was to reduce methane emissions from leaks in the gas transmission, gas distribution, and storage facilities here in California. And it essentially required that public utilities in the state of California, so such as PG&E, would follow these sets of rules and best practices established to perform leak surveys, the leak survey technology used, the types of metrics for evaluating and comparing leaks. So this made it that the operators, the commission, and the public all have accurate information about the number and the severity of the leaks, but also about the quantity of gas that's emitted to the atmosphere over time. So to carry out the intent of this Senate bill, the commission initiated the OIR and with a total of 26 best practices. And really the point was to reduce the hazards and advance the greenhouse gas reduction goals. So one of the best practices that actually drove the development of the Super Emitter program is best practice 21, which essentially stated that utilities shall repair leaks as soon as reasonably possible after discovery, but no later than 3 years. So as a response to this, in 2018, PG&E submitted our compliance plan, which was approved. And in that plan, we proposed this grade 3 below ground program. And again, these are the non-hazardous leaks. So the plan was to reduce the backlog and repair these leaks at a pace of about 2,000 leaks or so per year. Now, the average cost to locate and repair these types of below ground leaks is actually about the same for any size leak. So this is where our proposal came in and included this additional program, the Super Emitter program, that we would actually execute in conjunction because the potential emissions reductions from grade 3 leaks are actually much smaller compared to the Super Emitter program as a whole. So as Aaron mentioned, we ended up implementing this program in mid-2018, and we've actually since then refined the program to what it is now, which I'll go into more detail in a little bit. But first, if I want to move on to the next slide to kind of go over what Super Emitter actually is and some background on that. So the concept of a super emitter. So in 1996, the Gas Research Institute, GRI, and most recently Washington State University in 2014, observed that a large share of methane emissions of natural gas distribution system is due to the relatively small number of these larger leaks. So hence the name super emitter. And as Aaron mentioned earlier again, a super emitter leak by definition is one that emits more than 10 standard cubic feet per hour of methane. So really the main focus of the program is one, to significantly reduce methane emissions by accelerating the detection of these larger leaks, and two, prioritizing their repair. And that's really where Picarro comes in and helped us accomplish these two things. But before I get into that, I want to talk about the graph on the screen here. So this graph is basically showing the distribution of the leak size observed by both GRI and Washington State. So GRI's data shows that 20% of larger leaks, so again, ones that are greater than 10 cubic feet per hour, accounted for emissions, while Washington State shows only 2%. However, they accounted for 56% of total emissions. So based on that study, our research and development team proposed the opportunity to substantially reduce emissions by accelerating the detection of these larger leaks. And one thing to point out is that this practice is only to apply to methane emissions abatement. So it's designed to supplement and not replace the already ongoing compliance surveys we perform. And at PG&E, we perform this on a 3-year survey on our distribution system, which again is more focused around the safety and reducing the system risk. So with that being said, we can move on to the next slide. All right, so PG&E Super Emitter Plan. So how did PG&E as a company implement this concept within our program? As mentioned earlier, so we implemented the Super Emitter program in 2018. And at that same time, we were transitioning to a 3-year leak survey cycle as part of a different best practice from the OIR. So we went from a 5-year survey cycle to a 4-year, and then finally a 3-year cycle in 2018. And so because we were already using Picarro to perform a regular compliance survey, we continued to use their mobile detection technology for the Super Emitter survey as well. So the picture there on the top, you can see the vehicles, our drivers, and all the equipment that we use to perform these surveys. So the way that we accelerated the survey is by driving 2/3 of our system using Super Emitter technology. And then the other 1/3 of the system is captured via the compliance survey, also using Picarro. So in essence, our entire system is getting surveyed each year for any super emitter leaks. And so by accelerating the detection of these larger leaks, it leaves less time for them to appear, for them to grow, and it actually reduces the total number of larger leaks open in the system. So really to summarize that, super emitter is done in addition to our compliance survey with the intent of detecting these larger leaks faster. So they're not sitting undetected until the next compliance survey, which may occur several years later as part of the 3-year plan. So what I really want to note though on this slide is how we actually execute this program. So a couple of things. First, in 2020, PG&E, so we hired 10 dedicated drivers utilizing IBEW operator qualified personnel, so union employees to drive the vehicles and perform this work. Next, the process. So the drivers complete multiple passes, as Aaron mentioned earlier, on the same drive on every assigned plat map. And then at the end of the drives, our analyst team will collect the data, they analyze it daily, and determine any potential super emitter indications using the analytics. And then they send those indications to the leak survey field team, which then at that point, they perform the leak grading, the leak investigation, and the documentation of what they find. And again, these are the indications that are 10 cubic feet per hour. And I'm sure by the end of this presentation, you will all have that number memorized. But anyway, so our current best practice is that the field perform the follow-up within 7 days. And then once the indications are in fact actual leaks are graded and documented, they're then prioritized and then sent to our maintenance crews for repair. So the table on the bottom right, before we move over, I want to go over what our 2020 plan was. So you can see there, we actually don't ramp up super emitter until about the 3rd quarter of the year. We focus the first half on our compliance survey on the drives, and then we usually wrap that up around October 1st. Which then at that point, we shift all 10 drivers in the vehicles to the super emitter drives for the remainder of the year. So last year, we ended up driving around a little over 2.1 million gas distribution services utilizing Picarro. And then the other about 1.4 million services, or the other 1/3 of the system, was captured during the compliance drives. But again, during both types of drives, compliance and super emitter, it's important to note that we're able to separate the super emitter leaks and prioritize those for repair. So we're actually capturing the methane reduction there as well. So I just wanted to point that out. But Aaron, we can move on to the next slide. So getting into some data about the effectiveness of the program. So last year, again, we drove about 2.1. In 2019, we actually drove a little over 2.6. Million gas distribution services. Unfortunately, our 2020 data is not quite yet finalized. So the data that we're going to be seeing here on the screen and on the next slide is covering 2019 only. But in 2019, so pretty similar to 2018, we found 270 super emitter indications. We saw an overall methane reductions of 23%, which was an increase from 2018's 15% reduction. So we're definitely seeing the value of this program. The difference from 18 and 19 comes from a couple factors. So in 2019, we actually increased the coverage of the super emitter survey plan to include our San Francisco division, whereas before that wasn't included in the 2018 plan when we first rolled it out. So in 2019 and forward, we actually got the advantage of the Super Emitter program on a greater part of a system, really on our entire gas distribution system at that point. The other thing is there were more super emitter leaks the first year because the system had not been surveyed since the previous compliance survey, so it had been several years. And starting on that second year, since we're surveying for super emitter every year, we leave less time for them to appear and grow. But the good thing is you have less super emitters to repair, but at the same time, you've increased your methane abatement. So just quickly going over the two graphs there. So they represent the number of super emitters found by month and how many services we drove by month here at PG&E. And you can actually see the correlation there of more leaks found in Q3, Q4, because that's truly when we ramp up the program and really focus on the super emitter drives only. Next slide. I think this is the final slide here. So this slide shows a little bit of a different view. It's looking at a geographical analysis of the super emitter leaks found in 2019. And you can see that the indications are pretty much spread across PG&E's division. They kind of captured it everywhere. However, you do see spikes in certain divisions like Fresno, Kern, Yosemite, even Sacramento. So Sacramento is actually our largest division, but divisions like Fresno, Kern, Yosemite, those are located in the Central Valley. So being in more open areas with less obstructions, it really gives Picarro a greater ability to detect any possible indications. But with that, I'll turn it back over to Aaron to lead the Q&A session.
Thanks, Jessica. So we've got a couple questions here. One of them is, could this be a standalone program to meet code requirements?
Sorry, again, repeat that one more time.
Could this be a standalone program to meet code requirements?
So as part of the federal code here in the state of California, we do still have to complete our compliance survey. And as part of the compliance survey, we actually survey within 5 feet of the house and the buildings. We also perform our atmospheric corrosion inspections there. So again, this is a supplemental program that we have to do. And this one really focuses on the methane abatement, whereas the other program really focuses on safety and the risk reductions.
Okay. Another question is, in terms of the, for each leak indication, what is the correspondence between leak indications and whether or not you find a leak? So that essentially the no leak found rate. Comparing between compliance survey and super emitter survey, do you see a difference in the number of no leak found leases?
We have seen several no leaks found through the leak indication through the super emitter. However, we've also seen pretty high readings within the indications. I mean, we've seen readings all the way up to 750 standard cubic feet per hour through the super emitter, and anything below between 200 and 400. But I don't have that exact data right now to kind of tell you what the actual numbers are. But I don't know if, Aaron, do you have any additional data?
Yeah, I guess I don't know what PG&E's latest number on that is. The typical production survey on compliance, I can talk to that. The typical number on average across our customers in production surveys, about 15% of leases don't turn up a leak. And that's, that has various reasons. It could be a regulator burp. It could be the plume is outside of the leak indication search area. It could be that, it's for whatever reason, the technician that goes out to do the diligence on the LISA investigation just doesn't find whatever leak, or a micro. Centerpoint's talked about these things called micro leaks. So really small, we detect them with the car, but when you go out there, it's either the migration pattern is very large, and so with a handheld, you have a hard time finding the actual emission point. And so there's many reasons, and it's unknowable really why they are what they are, why you're not seeing leak indication. What I would say to your point, Jessica, because the super emitters are by definition just a much higher bent rate, I would expect that the no gas found or no leak found rate for super emitters would be much less than in compliance survey, because you're really, it's it's remarkable sometimes when we go out there, and we've done a study with PG&E where they'll go out and find an indication, and we'll go quickly out with a high flow to validate the measurement that the car makes, just from an R&D perspective. Sometimes it's hard to find where it's coming out, or the migration pattern is very large. And it's been surprising that you might have 10 or 20 cubic feet per hour, yet when you go in the field, you can't find where that is. And it's certainly a leak. I mean, it's got the ethane signature and everything, and it's got to be there somewhere. But for whatever reason, it's impossible to find. Some of these might be in like a busy intersection. So, unless you're going to close off traffic, it might be difficult to find those. There's others that have been in rural areas. And to your point, there's only one gas asset there. Where the heck is it coming out, and why can't we find it? So, the real world is stranger than fiction, I guess. Let's see. So we have a question. How do you measure the final emission remediation? Is it based on the methane collected on the initial drives, or is there some secondary follow-up that gets a final read?
That's a great question for our research department. Unfortunately, I don't do the final calculations myself, but there's a couple factors that go into that. When we do grade the leaks using DPIR, if it is a below ground leak, we quantify in parts per million. So there is that factor. Any above ground leaks, we classify them through the bubble size. And so we classify them through bubbles A, B, C, or D, depending on the size of the bubble, whether it's sputing or kind of slow. So there's a couple factors that go into totaling the full methane emissions. And I wish our R&D department was here to truly give you the answer there. But
so I can address a little bit of that. So Picarro calculates a number based on the multiple plume intersections that we have in each super emitter measurement. So typically, you might see it 4 or 5 or 6 times, depending on how many times you pass by it. And then there's effectively an average that is done to calculate the flow rate. One of the things we have done with Francois at PG&E and the R&D group is, again, validating that number. And I don't know if I say validating, but corroborating that with a secondary measurement, and that's using the high flow. And the high flow is great if you're familiar with the high flow. It's like an inverted bathtub, kid's swimming pool or whatever, where you're capturing the methane, and then there's a vacuum circulation with the DPIR, and it calculates what the flow rate is. That works great if you can capture the whole emission. And if the migration pattern is very large, you have a hard time accurately doing that. Or if it's underneath a tree or something where you can't really capture that, it's hard to get that. So yeah, we have done some comparison between that method and the Picarro method. In addition, and there's another question which I'll also answer: how do you quantify and validate the emissions reduction? So the validation really is about everything I just said. And then in terms of how do we know our measurement, how do we know the precision of our measurement? Well, we've done a lot of internal controlled release testing. We've done testing directly with PG&E at their leak test facility. We've done work with NYSERC. We've done work with GTI. We've done other work with industry partners to validate exactly what our precision is on that number. And so the important thing to note is, for the super emitter application, we're trying to tell the difference between 1 cubic foot per hour and 10 and 100 and 1,000. We're not trying to split hairs between 7 and 8. And frankly, there really isn't any technology that gets down to that level. And you don't need, for this application, you just don't need to. You're really trying to take, an 80-20. Let's scoop off the biggest stuff, and the precision that you've got from the vehicle measurement is well and good enough to do that. So let's see, there's a couple other questions here. Have you found any super emitters downstream of a meter? How did you handle these? I guess on the customer side.
yeah, again, I am not super in the data, but we would handle any super emitter indications as we would a regular LISA indication through our compliance. So those get sent out to our field employees. These are all operator qualified individuals, individuals with leak investigation qualification. So they'll go out there, perform their investigation, and properly document and grade the leak per our standards and procedure.
Right. And in other utilities, it's probably the same everywhere. If you're out there doing a leak investigation and you find you've got gas on the customer side, assess the risk. You might have to turn the customer off. Certainly, we've seen that at a number of utilities. The car, and the first example of this was with PG&E. There was, and I don't remember, Matt Smith might remember this if he's on here. There was a house and the garage had filled up with methane because I think the pilot light was out on the water heater or something. And the methane was coming out from under the garage door, and the car picked it up. And when we went to investigate that leak, and it was up on a hill, it was far away, we were surprised we saw it. But yeah, if there's a way for the methane to get out of a house, we've certainly, you certainly do what you would, in that kind of an emergency situation. And I think every customer of ours has seen this in some way. And I know after the recent, some of the earthquakes in Napa, you had a similar thing with Matt Smith talked about this in the AGA talk last year about the pipe that was venting inside the building, and that's, you see that with the car too. If it can get out, it can get out to the stream. Let's see. So, did you have any leak locations that you found year over year despite being previously repaired? How, if at all, does heat mapping of super emitters feed into decision making for capital investment?
Are you able to tackle that one, Aaron?
Well, yeah. Adam Ray from DTE is asking hard questions here. So have you seen previously repaired leaks turn up to be super emitters again, I think is the question.
Yeah, I mean, again, I haven't looked into the data. I'm more focused on the process and how we actually implement the work, but it's possible that we repair a leak and maybe something has migrated, or maybe it's a different leak that comes up and we're back there repairing another leak. But again, the great thing about this program is that we've accelerated the survey. So we're able to really identify those leaks right away within that year, instead of having to wait for the next compliance survey a couple years down the line.
Yeah, so I'll take kind of the second question that Adam raises based on what we've been talking with PG&E about. So there's this treasure trove of data, right? So we've got data over the whole system. We're certainly talking to the DIMP folks at PG&E about how to leverage that data set for potentially including it in the DIMP model that's used for capital replacement decisions. So all of the stuff that I talked about. And then certainly Francois is interested in and where all this came from in terms of using it for the DIMP model. Really started with Francois saying we want to look at how we can use this data to inform a risk-based schedule for leak survey, where plats are scheduled based on their relative risk from the data that's been collected on them. And because you've got annual data on everything, you can start to do that using not just is the plat up for survey, but within the DOT time frame of 5 years, you can push some plats out, bring some plats in, depending on what their relative calculated risk is. And so that's the kind of the second piece of what you might be able to do with that data, in addition to prioritizing capital replacement, putting it in the DIMP model. I have another question. Does PG&E drive each area twice or 3 times? If so, have you compared the field of view and indications found using fewer passes?
Yes, so we do drive multiple times. As we mentioned earlier, we do the 2 passes on each map. And Aaron, I believe you guys have done several studies, right? Comparing the different amounts of drives, and the most effective was doing multiple passes because of the changes in the atmosphere, the wind and the stability and whatnot. I don't know if you had any more details around that.
Right. So you get the reason the protocol, the recommended protocol from Picarro is, and it's very specific. It's not two drives with 3 passes. It's 3 drives with 2 passes over at least two different nights, because the separating it into 3 different chunks. If I'm doing 3 passes on the same night, I'm not getting as much wind variability as I would if I did, 2 passes at 10 p.m. and 2 more passes at 2 a.m. And so when you do that, you really maximize the field of view. And if you're comparing a total of 6 passes to a total of 4 passes, not only is the field of view reduced by 10 or 20%, so you're potentially walking more gaps. The important thing is, from a compliance perspective, you're reducing the probability that you're going to see the leaks from about 95% down to something closer to 70%. So to get a really high leak detection probability, you need six passes total on each street. And again, to get the field of view, you want to make sure those are spread out in the way that I described. So that's been an important thing. I think that, correct me if I'm wrong, Jessica, that in the interest of resources and timing at PG&E, I think you've elected for a 4-pass protocol for super emitter and a 6-pass protocol for compliance. Is that right?
Yeah.
Yeah. And so, in that case, you're doing, as well as you can. You're utilizing that that equipment and that labor, and PG&E's got a big system, 43,000 miles or whatever it is. So with what you have, that's what fit in there. We'd love to see you do 6 passes, but again, the point is you get great results in any way you can do it. Let's see. So to clarify, this is a clarification of this last question. To clarify, Picarro protocol suggests 3 drives, but it sounds like you have chosen to do yes. So I think I just answered. He wants to know why you've chosen that 4-pass protocol. Maybe I already answered that a little bit.
Yeah, I think you pretty much covered it. With the dedicated drivers, right? So that first part of the year, we're driving all of our compliance drives. That's about 1/3 of the system. So about a little over 1 million of those services are actually getting more than the 4 passes, and then shifting that to the super emitter, we're doing the 4. So I think we're really maximizing the value by doing those multiple passes. We've really seen, more accurate data, better data come in by doing the multiple passes. And I mean, we've piloted this. We've been with Picarro since 2014, right? 2013.
Well, Matt and I started working back in 2012, but that was the R&D days. So
yeah, so there's definitely been a lot of trial and error here to get to the number that we're seeing really good data come in.
So another question, Jessica, do your leak survey technicians also cover atmospheric corrosion compliance requirements every 3 years? And do those same technicians find and grade the super emitters once the data is compiled?
Yes. So actually, starting this year, we are fully aligned with our atmospheric corrosion program. Before, it was a different department taking care of those inspections. But now that 2021 is the new start of our 3-year cycle, so we're fully aligned there. So the technicians do perform the survey and the AC inspection all at the same time, and those are the same folks that are doing the super emitter indications once those are compiled. So the drivers are a little bit separate from the actual field technicians, but the drivers also have the same qualifications to perform those inspections as well.
Okay, another question is, what is the average time span between when a super emitter leak is found and then evaluated and responded to by the field team? Have you encountered situations where a response was not quick enough, i.e. gas migrating into a house or a foundation of a structure?
That's a good question, because there really is no standard in doing this, right? We've kind of built it on our own, and as a best practice, we chose to do the investigation follow up within the 7 days of any super emitter indications. Have we encountered situations where the response was not quick enough? So really, we're looking at the highest reading, right? The 10 standard cubic feet. When we're doing the super emitter drives, there's really no interruption. So we're just driving throughout the whole night. The vehicle doesn't stop. That's a little bit different when we're doing our regular compliance survey. If we do get something that is, abnormally large, potentially hazardous, we do stop the vehicle right away, get out and perform our investigation. And so we haven't run into any issues since we started the program.
Okay, another question. When you started the emission program, was it before or after using Picarro for your normal surveys? What type of effect did it have on the resources?
So we started Super Emitter using Picarro after. So we already had been using Picarro for our regular compliance survey since, Aaron goes back to the MAT days in 2014. The resources, we did see an effect on resources when we first kicked this off in 2018. So we were using our regular technicians. So there was a lot of increased overtime. We saw some capacity issues with those employees that were driving the night shifts. They have their rest period recovery. So we're now short an employee to perform the regular compliance survey. So last year, that's when we said, let's get this dedicated shift. So these 10 drivers are on a 4-10 schedule. So they work Monday night through Friday morning. So they drive 8 p.m. to 6 a.m. So now it's a dedicated role for this position, and they drive the full year. They drive both the compliance surveys as well as the super emitter surveys.
Okay, and one last question. In terms of the deployment, are you both working with other utilities, industries to deploy the technology and lessons and improvements? I guess that means both you and I, Jessica. So certainly, yes, on the Picarro side, we have taken learnings from lessons learned across all of our customers and developed the recommended best practices and protocols that we, when we stand up a new customer, we bring all that knowledge to bear to benefit and accelerate the deployment and success of new customers. And PG&E has been a fantastic partner and has spent untold hours with prospective customers all over the world to bring them in, have them ride along and tag along on the field work and to describe their process. Jessica, you've probably been involved in that as well.
Yeah, so our research and development team benchmark across the nation and even in different countries too. We're part of I believe it's called the NY Search. I may be wrong on that name, but we're constantly looking at other utilities, seeing what they're doing, what their process is. We work really closely with our, sister utilities down in Southern California, SoCal Gas, San Diego Gas. So we're constantly looking at, how can we improve this program, and even internally too. Every month we have our tech team looking at the procedures, looking at the standards, seeing how we can improve and whatnot.
Okay, I have a few more questions here. What is the breakdown of leak survey environments, urban, rural areas in which these surveys were conducted? Have you noticed significant difference in the data gathered from each environment?
Yeah, so PG&E, we cover a large part of California. So basically, Bakersfield is our lower southern border all the way to Eureka, so right by the Oregon border. So really, we range anywhere from urban to rural. So we've seen our highest reading for super emitter was in our CR division, which is around our Chico, Olivehurst area. So that's a little bit of rural and suburban. But then we've seen a lot in Stockton, Bakersfield, Fresno, which is more of a rural area. So it kind of ranges. But again, going back to that one graph, a lot of our leaks, we've seen a higher indications in our more rural areas.
Another question. I'm in Washington State. Could you conduct a super emitter survey during the winter season, say with snow on the ground but not raining? So I'll tell you what other utilities have done. Certainly, yes. Gas gets out from snow and under ice and everything. We've done a number of these things in New York State. It's used in Minnesota. So the issue with surveying during those seasons is follow-up. So yeah, the car detects it just fine, but going out there in the rain with a handheld or digging through a snowdrift for a leak is the harder part. And Jessica, you guys have some of your own experience there too.
Yeah, we have areas, all the way up north in Eureka that does get a lot of snow. So like Aaron said, the challenge is not driving the vehicle. The challenge is mostly with the follow-up, right? We have our rain checks that we perform. If there's a heavy puddle out there, we're not gonna be able to quantify it accurately. So we want to make sure we go back and get accurate results. So that's really where the challenges come in, it's the follow-up.
All right. Well, I think the audience has exhausted all their questions. Hopefully, we've answered everybody's questions, and please don't hesitate to reach out to either Jessica or myself if there's things that we didn't address here. Certainly, Jessica, thank you for your time. Thank you, WEI.
Thank you.
Thank everybody that attended for your time and attention. And let's see. Okay, hang on. Just yeah, we can reach out with our contact information as well. That's one question that just came in.
Yeah, definitely. I know there was a couple questions on some specific data. I'd be glad to follow up with those who have more interest and want to know more about our data. I can touch base with our R&D team, grab some of that data, and kind of walk you through some of the results we've seen. I'd be happy to do that.
Great. I think, oh, hang on just a second. There's a couple more questions that I just saw. That one quick question: how many survey technicians are assigned to each car?
So we have 10 cars and 10 technicians.
Okay, so each, but the car is a single driver, single
Correct.
person. Yeah.
Yep.
Okay.
And the car covers several divisions. So we try to, geographically place people. I mean, we have a large service territory. So maybe a technician in Bakersfield covers all the way up to Fresno and whatnot.
One final question. Have you noticed a reduction in odor calls as a result of the super emitter efforts?
We have. But again, those odor calls, it really fluctuates. I mean, historically, we have seen a little bit of a reduction before Super Emitter even came along with, increasing the survey cycle from a 5-year to a 4-year to a 3-year. So doing it more frequently, we are seeing a reduction. Now adding this additional supplemental program, we're seeing the consistency there.
I think the one data point that I saw from PG&E we looked at with you guys a few years ago, it was either between 2017 and 18 or 18 and 19, was a 14% reduction in that year. And I don't know if that's been tracked recently, but that's the number that sticks in my head. Anyway, we're out of time. We will follow up on questions we missed, and we'll certainly follow up with contact information. Again, thank you, everybody, and have a great, safe rest of your day.
All right, thank you.